Hello, guys and girls. This is Lekshman here. Welcome all of you to Global Coding Cohort. And in our previous session, we solved part of a particular problem. Yesterday itself, I mentioned in that. And today we are going to finish that another second part of that problem. So, due to that, I'm going to tweak this uh, problem statement. Yesterday, I wrote only its half. Today, I'm going to fulfill it. Okay. So, if anyone is watching without watching yesterday's session, please make sure that you watch this after you watch yesterday's session. Okay. We'll not be repeating the entire problem statement. Uh, I'll just be editing and I'll explain only those parts. So yesterday we just printed if there is a path found, isn't if there is a path, we just printed path found. If there is no path, we didn't print anything. But today we are going to do that also. We have to print this place yesterday none. But today path not found. Then today we have to plot the path. Okay, so like this. Copy this arrow mark. So like this, we have to plot our path today. Means this arrow mark defines the path from where we came. Okay, not about where we are going ahead. To this point, we came from this 0, 0, isn't it? So we gave a right arrow mark over there. And in this case, we visited this location from top, isn't it? So we gave this arrow mark here. Now, entry and exit, we need not replace it with arrow. Okay, so they are starting and ending. So I edited the input, isn't it? Sorry, I should not have done that. Yesterday we start just by printing path form, but today we have to go a step ahead. We have to replace that with S. This is sorry, replace this with with S, and this destination is D. Okay, source as S, destination is D. Here we do not need to print any path because there is no path for this second scenario. Okay, so this should be printed only for those names with path. Okay, I hope this is clear for all of you. So now we'll start editing this code. Okay, this is we have a path. Today I will not explain how this code works. I will explain only those parts with where I'm going to edit. Okay, to know more about this algorithm, you have to watch yesterday's video. Today I'm going to return path found. Okay. Just printing over there, I'm going to return it. As we are using recursion, wherever we call this function, if there is an output, it will return it in that case and factor uh, to capture those returned output and assigning that function called to a variable called out. I'll try to print if there is any out, then it will return it, else it will throw an error. We will handle that error and will print path not found. Okay. This is how today we are going to let's check. This one has a path, isn't it? They will fix it for it. So whenever when nothing is returned, I have to cancel that exception. We didn't do that, that's why. That may be one of the reasons for this error. check fixing. Because even if out is not initialized, I'm expecting it to throw an error at this point. Okay, this has an output. Obviously, that should come, or that should return this smartphone thing. Instead of that, it is expecting it to work in that way. It is returning error. We got smartphone. So it is returning smartphone now. Now let's check if we are getting an error. We are expecting an error. Okay, when there is no path, we are expecting an error. So let's check. This will not have a path. Check. Okay, as expected, we got an error. So at this point, the will print path not found at this place. Print out variable. This is how we are expecting to work. Whenever we call, we have to copy this. Those are global variables. They're going to be used in the function. We have to reinitialize it every time we run the code. We call this function. Okay. Now we have found whether path is there or not. If path is there, uh, I have to trace it. Okay. I have to trace it. Only then we can print out this. So first of all, I'm going to trace it. For that also, I'm going to use a global variable trace. Whenever a branching is going to be happen, then like that. So from now to next point, okay. Because here is where something is going to take a new diversion. That's why tracing out. The direction may be either in the same or in a different way. Okay, we have four directions. For more details, you can watch yesterday's session. I'll explain there clearly about this. Let's generate a put with path. So this one has a path. Run it. And has a path open. Yeah, this has a path. But still we receive path not found. Okay. Instead of this, we will see the error. First we will check simply. Okay. Right now. Like what error will we get? Oh, sorry. Do this. Do that. Right. Now let's find out once again. Now path found. Okay. So we have a global variable called trace, where we are tracing our path. So here we have got something like first we have to start from our destination, okay? Because there may be some other path which should not have led to destination, okay? So there will be n number of paths. For example, like this. So there are nine, no path, testing, okay. Here there may be a path. This is the actual path, okay. But it could have tried to come in this way also. So there may be an incomplete path which got blocked at this point. Correct. So that therefore we should not start tracing from our starting point. So we have to go for a reverse way so that we will be able to get trace our that final path. Okay. So this is our name going to replace the dots with the path. Okay. Let it be like this. If we need to change, we will change that later. That later. Okay. Start. Robust, that's why I'm using something like or it's better to child. I will loop it, no problem. So loop it. Oh, this is just to loop it means I have to find length of it. Uh, for that I have built-in functions also, but still here I'm going to write custom uh, function to find the length. Okay, but while you develop a software, you have to wherever possible you have to use a built-in functions. Okay, set up this is a coding session. Trying to solve it now wherever possible. Starting 0. I have explained this logic also in some of our previous sessions. Watch all our previous videos. You will understand. Trying to then we're going to go to count length and this also going to act as a variable of input. Then we're going to add both the inputs as a length count. Okay, that's it. Which is there by one. Okay. It will throw an error. We will handle that. We will break that loop. Finally, we will return our length variable. Uh, we check it. Uh, Solve it. Something wrong. Let's check it. Sorry, not zero, but length. Okay. So now it should have correctly. So let's just stick it. So it's of this. So not zero. But space. File. We are equal to then this uh, space of I of second variableism. So let's take it as mine. Anyhow, second is your last. There, there, there are only two numbers inside each list. So I'm going there. equal to. This is our destination. Our destination is fixed, isn't it? For all input, it is going to be same. Replace previous with uh, place of I. 0. So its previous, its corresponding previous location is replace previous with this one. Then this point which try to replace this replace this with current variable, current equal to not I is it. Sorry, that's fine. Current of 0, current of not found. Like this. We are accessing, okay. To that number we are accessing our means to update that with the one. Final path, okay. I'm taking a variable called final path because as we are going in reverse, we cannot find from where we came here. If we just take its previous one, uh, there are chances from where it could not have arrived. Okay, that may be endpoint of some other path. Okay, so that's why we are creating another variable called path. There will be storing our final path. So in this place, we need not update it. We will just trace the old path. That's it. Not update it here itself. So current final path of dot up and down. So 3 if 3 is then uh, if current equal to previous. This is for the first one, okay. From where we have to start. See, at this in this scenario, 4 is here, not the last one. So till that it will not get executed. That's why we initialize previous as none. Things get things get started only after this point, that is like the initial realization point. Realization point to get appended, okay? We are finding our final path, okay? Listen. So this is the point where from where it's, path gets appended to our final path variable. So once that is turned on, further previous got updated with an evaluation. It is no more done. So this will get executed for next one. Then for 3 equal to 4, then now we will append previous 3. Hope this should work fine. Okay, somewhere going on. Let's fix it. For dot point, is it going out? Nice. It's length, total length, total length. Where is it? Oh, okay, okay. 16 is not available. Reduce. Let's set our final part. So it is this. So we have reached our source. Now let's try to plot again. For this also we have to come backward. So backward action. Cross, reverse. Okay. Right, right. We will start from second last. Okay. By default, uh, zero comma yes, to the destination. Put it somewhere here, or no problem. Let's see here. So because of that, will start from greater than 0. Will not uh, come even to 0 temper. Because already we have 22 is a source and destination. So we are just starting from second last. Uh, so 3 is final path dot 1. So this is 3. Current is going to be a final path of. So at this point, more directions in the reason. Based on that, we will have to replace that with the perspective arrow map. Is arrow map. So it will be for us to replace current of I of 0 current of, sorry, 3 of is with this case current of is not -1, this is +1 in our case. We are going as we are going in reverse with +1. Only then when we stand at this point 1 comma 0, our previous will be 0 comma 0. Okay. Then the current is second question element column. Yes, if it is greater than our previous of 1, then that is direction, that's right side direction. It means our right side of one comma 0. Current of with direction. There is no equal to scenario. Okay. Oh, sorry. I copy this. Then there is, if it is wrong, we will change it later. Okay. No worries. Let's think a lot. Really. Current of uh, 1 equal to current of previous of 1. That means if the column is same, then that would have moved in upward or downward direction. So current of 0 greater than previous of 0. current is greater for the angle. Oh, sorry, I didn't hit him in the eye. That's why. But up with it. Apparently, we should be more careful. So, check our name. Our path is plotted. But still, we have some problem over here. You can see over here. It's coming. Yeah, it can directly come here, right? But instead, it is turning. Oh, we have to check our path. 001011. Able to see this is fine, but at the end, turn down. Let's check or trace. From this point, this is fluid coming reason. Fluid coming 3, 2, 2, 3. So then from 2, 3, it is come. Okay, okay. So it has found a path. Actually, this is not the shortest path. Okay, it's taking 2 steps more. Shortest path is directly coming from this point to here. So let it be like this for this session. We will we didn't mention shortest vision. So no problem. We just need a path if there is a path, but we did not mention that should be a shortest path. We will consider that as a no problem and we'll solve it in some other session. Okay, in any of our upcoming session, we will solve that. We will find shortest path. Okay, but for this session, for the scope of this particular problem statement, this answer is correct. Because we did not mention that has to be shortest or not. We just need a path. That's it. But no worries, we will solve. We will find a shortest path in some of our upcoming session. Okay. Then finally, our maze is ready now. Finally, we have to beautifully print it. So, okay, take this code and instead of those, We'll make this as a function. Class level 50. String. We'll just simply beautify. We are going to beautify this even class name to generate the value. Copy this over here. Function that will be there and equal to oh, value at the end. I can beautify out print out. But what about S and D? We updated it. It isn't. S and D is getting reflected. That's why beautify is by default making this something like this. So what we will take this out. We'll make that manually. Let's just give a condition simply out is true. If it is for output, then it should not run. Okay. If it is false, it should run. So here from the out equal to false. By default, I will be giving out equal to false, double equal to here. Then I will pass out as true. Why is it not running now? Oh, sorry, sorry. Out is work. It is okay. Here we have a path for the bank opposite not found. There is all this. Very that's it. uh, problem. Okay, so for this case, else this one should come over. Problem instead of putting delete it, we'll take this condition up. Now it should work perfectly. Yes, it's perfectly. But I have to handle something here. Only when start is point, we have to execute all these steps. Copy that, paste it over here. Fine. Then this part, plotting part, plotting part is our final print. Let's check it. Let's bring our input generation code here. Or else it will be there, no problem. We will do that. So we have a path found. So again, these unwanted moves are there, no problem. I will. This is correct for the scope of this particular problem. Okay. Check for an path two. How this is rotating. Just for command testing. Okay, fine. It is going to rotate heavily. See, it's taking extra step and time. This house of path. This do not have a partition. Let's check for this. The path not. So our algorithm is working as expected. I hope all of you understood this solution. That's it for today's session. We'll meet you with another problem tomorrow. Until then, bye bye.